already.
That's the scary thing.
Ready to learn.
That's great. That's what I'm talking about. I hope this goes quick so we can get caught up a little on homework questions. I hope this is review and you have this down cold, and it's only a quick brush up, not a whoa, I didn't even know that kind of thing. But we'll see. We'll see. Okay? Yeah. No, you'll be fine. This will be. Yeah, I got that. So this are transformations. This should be a review. It's a pre-calculus idea. This is a green chapter. It would be in a pre-calc / limits chapter of a calc book. This is something you use in calculus, knowledge of graphs and how graphs are transformed. This is more of an AP style approach to it, less of a one we're used to. So it'll be good practice. For all these, there are I'm going to go through 4 ways to change a graph. Okay, you could shift it, you could stretch it, you could do something else. What else? Reflect it, or you could absolute value that bad boy. You could also take reciprocals and inverses, but I didn't do that today, so we'll do that another day. So here's the deal. This is the graph we're going to be working from for the whole time. And the first and foremost thing is, if you're iffy on this, you have backup. Backup at all levels of graphing is a table. If you're not sure, make a table, make a table, make a table. Check, 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 check. Okay? That's how you learn to graph from the beginning. If you remember back to pre-algebra, when you graph this, you started by making a table. That's still there as a safety net. Don't lose that, because these can get complicated. Now, by way of reinforcing that, let me talk to you about what a table would look like. If I were asked to graph that, it's pretty gross, okay? There's this absolute value in there, and that does something, and then there's the 1, and that does something, and the negative does something, and the 2, that's 4 transformations in one. That's a lot to wrap your mind around, okay? The table helps you a lot. This is what it's going to look like. Say this g function is the transformation or transformation of that, okay? If I wanted to say, what is g doing at -4, I could put -4 in and see what happens. G of -4 is 2 minus f of the absolute value of, let's do a little work, say, absolute value of -3. Wouldn't you agree -4 plus 1 will be -3? Okay. Now, working through this, what would you do first? Absolute value. So the absolute value, I'm going to do some of this mentally. The absolute value of that would be 3. So 2 minus f of 3. Okay, now what do? I go here. Okay, now I can't really take 2 minus this until I know what this is, right? So f of 3, I go to the graph. I say, oh, f at 3 is -3. Okay, you're looking at the x. When x is 3, the y that comes out is -3. So I'm getting that point, right? So the outcome to that would be -3. 2 minus -3 then is, yeah, south of the border, that'd be 5, right? Right. Okay, try -1, please. What are you getting? -1, I agree. Okay? If you didn't get -1, then talk to me. What did we do wrong? If we're all good, then do the next one. What are you getting there for 2? 5. I agree. All right. Absolute value of x tends to make negatives and positives behave similarly, and so we'll get to that later. But if you got 5, then you're on the right track. Are we doing okay so far? Okay, good. All right. Again, I don't want to go through this too quick, so if I'm going too fast and I'm not hitting this, please slow me down and tell me. So when you shift a graph, you do it by adding or subtracting. And depending on where the adding or subtracting happens, it'll make it either a horizontal shift or a vertical shift, right? what if you add inside on the x? You're changing x, so it would make sense that you would change the graph horizontally, right? X is a horizontal measure, so this would shift it horizontally. The question then is, would adding one shift it right one or left one? Left one, okay. So it sounds like we have good knowledge of that. This point, -4, -1, I guess, would become -5, -1. This point here, which was -3, 0, would become -4, 0. That point there is pretty interesting. That 0, 3 is going to become -1, 3. I have this kind of quarter circle thing going on. I guess that point is, I'm pretty sure that point is 1.5, 0. So it'll become 1.5, 0. And that last point of 3, -3 becomes 2, -3. You agree? Okay, try the next one, which is obviously different. Adding to one outside the function is changing the function, which is changing y, and therefore a vertical shift. Okay, shifts vertically. See if we agree. Graph looks something like that. You could check your answer by one way by this. What's the range of your new function, the range? From -2 to 4. Okay, remember range is y, low to high. Okay, sounds good. Sounds like you're good there. Let's move on. When you multiply or divide by a factor, you stretch the graph or squish the graph, depending on where it is and what kind of number here. It helps me to think sinusoids when I do this. You're probably the same. You're probably pretty good with sinusoids, and so if you think of what does this do, they say, oh, I know that changes the period to, instead of 2 pi, it changes the period to pi, right? Remember, period is always the normal 2 pi divided by the coefficient, yeah, of x. So in this case, 2 pi divided by pi would be, or by 2 would be pi. So in essence then, this caused the normal wave to condense into a much quicker wave, yeah? So what will that 2 do? Multiplying inside causes a horizontal squish in fancy math terminology. I have yet to find a textbook with the word squish in it. I cannot figure why that is. I guess it's not mathy enough, but that's how people think about it, and that works for me. So let's go here. -4, -1. Where will it go? -2, -1. Okay, so -2, -1. Now, say this is a test, and I have a little extra time, and I want to check. How can I check if that point is starting off in the right foot? Yeah, make a table. Check this out. If I put in x equal -2 to verify, it should come out -1 according to what I just said, yeah? If I put in -2, what's 2 times -2? And what is that for -4 according to the original f? -1. It's working just great, right? Okay. So what about this point here, which was -3, 0, -3/2, 0, yeah? What about this, which was 0, 3? 0, 3, you'll find the 0 stays the same because taking 2 times that doesn't affect 0. Let's go all the way to the end point. We don't really need the midpoint because it's a straight line anyway. So let's go all the way to the end. Where will 3, 3 go to? 1.5, -3. So this. That's supposed to be curved. It's not very good, but yours should be better because you have a pencil, not a marker. Okay, so if multiplying by 2 inside causes a horizontal squish, then dividing by 2 inside causes a horizontal stretch. Okay, so critical points. Give me a critical point then, a starting point on the far left, which I didn't give you enough room for. -8, -1. My bad, I think it ends in -7, doesn't it? Okay, sorry, figure it out. You just borrow from the other graph. How's that sound? What about this point, which was and then becomes? Tell me what it was and what it becomes. It's definitely a gap there. I need to calculate this again. I'm sorry, say it again. -6, Okay. How about that point up there? 0,3 becomes or stays? 0,3. So we have this longer. And what about the far right point? 3, -3. 6, -3. Okay, cool. What about multiplying outside? What would that do to a sinusoid? What's the number out front called in physics or in math too? Coefficient is it causes the amplitude to change either way, yeah? All right, so will the amplitude be doubled or squished? Vertical stretch or vertical squish? Vertical stretch. So would you quick jot these two down and we'll move along. The x will stay the same. Notice this time the x stays the same, the y changes. Something like that, yeah, it's supposed to look curvy. Okay, so far so good? Something like that? Except better, I hope. Cool. All right, shall we move along? All right, reflection. What does reflection cause? Never mind. That's a stupid question. How do you get a reflection? What do you do to the equation? You do get reflection by a negative strategically placed. Okay, therefore changing the sign of x or changing the sign of y. If you change the sign of x, then you're going from x's to negative x's. If you flippity-flop these, then it'll cause reflection across the y-axis, right? Not because y is what's being changed, but because that's the dividing line between positive and negative x's. So we're switching around that axis. We're spinning it around that. So tell me what the graph will look like. Line on the left, curves on the right. So -3, 3, and up to 3, 0, and then semicircle, or a quarter circle, excuse me, and a quarter circle. Like that, yeah? Negative outside, that's changing the sign of y. If you change the sign of y from negative to positive, then we're going to be flipping across the x-axis. So tell me, it would be more like line going up to the right, and so I still have the line on the right, but except it'll go from 3 to 3, it go 3, 3. That maximum will now become a minimum at -0, -3, and then quarter circle, like that. Yeah? Like a funny V. All right, now the absolute value is the hardest one. Okay? This is unbad. Absolute value, people tend to be fine with one of these and not so fine with the other. This is the one they're usually fine with. Can you tell me what this graph would look like? Absolute value of F. Actually, let's go here. Big idea of absolute value. Yeah, big idea of absolute value, it does not change positives. It makes, as far as negatives, it makes negatives into positives, and therefore it makes negatives behave like positives. So, with that said, this guy, is it going to take the absolute value of the x or the y? Of the y. Okay, it's on the function, so it's going to make positive y's are going to be unchanged. Negative y's will be made positive. So, with that said, look at this graph here. Where are the positive y's? They're the ones that are above the x-axis. What happens to them? Nothing. Yeah, it stays the same. So the quarter wave, or quarter circle here, and the line there, no change. Absolute value of the positive is the exact same thing. What does change is the negative y's. When I put in -4, I would get here -1, but then the absolute value comes in after I evaluate the function, and it makes that -1 into +1. And so it causes that -4 point to flip up. Likewise, this point, when I put in 3, I'm supposed to get -3, and I do, but then absolute value makes it +3. And so it'll take all the points below the axis and put that. Now that's the one that most students do well. It's kind of fun. This one is the one that gives students, not talking BC students, too, trouble. People tend to muff this one. So let's stay true to the big ideas. Absolute value on the x for positive x's, no change. Let's tackle those first. Where are the positive x's? On the right side of the graph, yeah? This side will not be changed. Now this is the part that's hard. Negative x's will be made positive, and so they're going to behave like positive x's. But then those are put into the function. So that's what makes this kind of funny here. Look at this point here. If I put in -3, that's 4, sorry, -4. If I put in -4, absolute value comes first. It gets made to, we have a bit of, yeah, this is going to be bad. That's okay, no big deal. So anyway, -4, if I put in -4, it gets made positive, and f of +4 is f of +4 is those of you who are not saying anything, good job. You should not say, you're supposed to be doing this right now. Go ahead. Boy, that's good stuff in calculus. You get a great workout in calculus. Because if you do that every time you don't know, man, your shoulder's huge. F of 4, here's F. When I put 4 in, what do I get? There's no point there. That's not there. I don't know. Let's go to -3. Now, it feels like it should be some kind of curvy thing, but it actually has nothing to do with the curve. Try it. -3. What comes first? Into the function or the absolute value? Absolute value. So, -3, absolute value becomes +3. F of 3 is negative. Oh, wait a second. Oh yeah, you're right. Sorry, it's a good point. F of 3 is -3. And so, this is actually just like that. What about if I put in, it's going to sound crazy, but put in negative 1.5 for me, please. What do you get when you put in negative 1.5? 0, yeah, because negative 1.5 gets made positive 1.5. F of positive 1.5, according to this, is 0. And so, oops. Now you might say, what about the circles? Never happened. Never happened. They're gone. Bye-bye. The only thing that happens is this. Negative x's are just like positive x's. So it'll be a reflection of the positive x values. Negative x's are just like positive. So the right side is going to happen again on the left side, and that which was on the left side never even happened. You follow? Okay. That's it. Yay. All right, let's get caught up, shall we? We are so behind. I would like to get at least 2 homeworks in today. If you can get all the way caught up to 3, that would be even better. I'm giving the SAT tomorrow, so if I have stuff to grade, that's super. Anybody taking the SAT chapter tomorrow? Okay, I'll see you there. Maybe you'll be in my room, maybe you won't. If not, get your butt up and go to the dash and run, you lazy weasels. All right. Don't be giving me that sleeping in stuff. You know, are you guys running tomorrow? No. Aren't you athletes? Yeah. Aren't you training for basketball? Would that help you for basketball? It would. It would. Okay. All right. On IVT, I can't. I have the key up there. I think. Yes. No? Yeah, it is. It's up there. Just so you're aware, I share it to Jeffco Schools, so if you need to view anything that's a document, you have to sign into your Jeffco Schools thing to be able to see it. Okay. And then that's all I really know. I'll leave it that day because I don't really know how it works, but you figure it out. So that said, do you have any, yeah, I saw your key, but I still don't understand what's going on kind of thing, questions on the IVT sheet. I believe it's what? Yeah. Number 4, okay. Yeah, this one's tough. This also, some of the questions you'll see that I give the same question to AB Calc and BC Calc. This one's pretty well kicked their butt too. This is more, the AP style, IVT can be hard anyway. The AP questions are kind of hard. The college kind of IVT questions are a little more gray area and they're harder. But once you get good at them and get enough practice, they're not bad. My thought process is this. I read this, should there have to be a solution to this? And that's so ugly, I don't know, maybe I don't. So you fight the temptation to pick up your calculator, which would surely get you started and is better than skipping it altogether. But this is the thought process. Think about what this would do graphically. This would go this way, yeah? And this would do this kind of thing, and this would be a shift. But in terms of the whole grand scheme of things, big negatives, 0, big positives, if I put in a really big positive, let's say x equals, actually let's put in a really big negative. X equals negative 10. What's the dominant, what gives the biggest results? The cube, the sine, and that's just a constant. Which dominates? The cube. Okay, the cube gets really big. For example, at negative 10, I get negative 1,000. I'm going to write it this way. I'm going to call this, let this be. This. Okay, f of negative 10 would be negative 1,000 plus, I have no idea what the sign of negative 10 is, but I don't need to, minus 1.2. Now, it's not important that you tell me what this exactly equals. All that you need to really tell me is that it's either positive or negative, and you'll see why in a second. Is this going to be positive or negative? Why? You don't know what sign negative 10 is. How do you know? Beautiful. Beta sign can be as 1, and the least it can be as negative 1. So regardless if this is positive, I don't know if that's positive, but it's never going to overcome that guy because the most it could be is positive 1. And so this is definitely negative, which you can write the word negative or you can write less than 0, and both are fine. Symbols mean less writing, that's what it says. Okay? Now remember, the idea is why it has to, whatever this curve is, has to pass through 0. We showed it's negative over here. What do you reckon we now need to do? Yeah, we need to show that it jumps to positive. So what should I, it doesn't tell me what to try, like some of the problems. What should I try? Choose something that you know will make it positive. 10. Okay? X equal 10. F of positive 10 would be 1,000 plus sine of 10, which I have no idea what that is. Okay? Now, whatever sine of 10 is, it's not negative enough to drag this into negative territory. This must be positive. Okay? Now, it just occurred to me that I forgot the very first step of an IDT problem. You first establish that this function moves continuously. And I screwed up and nobody jumped in, so shame on you too. Okay? This function, f is continuous. You don't have to rigorously prove that. In my mind, I'm just thinking x cubed is continuous, sine is continuous, the combination is continuous. Okay? It doesn't have any jumps or holes or any funny business. It's going to move smoothly. All right, so if f is continuous and f goes from negative 10 to positive, from negative to positive, then can't I say, and sorry, my work's really poorly organized, but f must equal 0 at some x between x equal negative 10 and 10. Actually, what am I saying? I should say this better. F equals 0 is between these two, negative and positive, something like that. It doesn't have to be said just like this. You might be saying it better than I am. My conclusion then is IVT, state the question kind of thing. By IVT, f, or the function, must equal 0 at some x between. Now, according to my work, I chose negative 10 and 10, so I should be saying at some x between negative 10 and 10. If you used, negative 5 and 5, then you say negative 5 and 5. You with me? Does that make a little more sense? Yeah.
Should we be showing that kind of word, like just a positive rather than positive numbers in the question?
If it's a no calculator problem, if you had your calculator, you can report the actual numerical value, and that's great. I would put this on a no calculator problem, and so you kind of just go general negative, and there is an AP question like this, and that's the expectation. You just say, I don't know what, but good question. Other questions on IVT? All right. So my goal this week was that you get a feel for IVT, start to get a little better and better. Yeah.
I actually have a question on 11.
11? Okay. 11. This, if you have your eyes open as we're going, then you start to get a feel for, oh, he was trying to get us ready for derivatives. So this is my goal here back on Monday. The average rate of change is the same as the secant slope, yeah? So it is change in y over change in x. And so in this case, part of me looks back at this and thinks, I'm not sure if this is clear. You understand that this is an interval notation, right? That's not a point. I had some people treating like that was an xy. That's a interval of x. You with me? Okay. So that said, then the points you could say are 2f at 2 and 2 plus h, f at 2 plus h, that we're using for our slope calculation. And I apologize. Maybe I should have used inequalities for this to make the problem clearer. Sorry about that. And furthermore, I would lose points on an AP test because I'm not in the problem. The problem is I'm using f. I just used f. And in this problem, there is G. You gotta go with the guy that brought you to the dance, okay? And so G is the one that brought you to the dance. Don't go out with F. So here, G of 2 plus H minus G of 2 over 2 plus H minus 2. That represents change in Y over change in X. That's average rate of change. That's secant slope. They all are the same thing. Really, other than the denominator, I really can't do much more. I didn't identify G. The question was I wanted you to make sure you use G, not F. That's the point of this question. So the top is done. The only thing I suppose you could do, and you didn't have to do this in 2 steps, is just to call the denominator H. Now that would be secant slope between a defined point 2 and some other point, and then with the limit the next day, we've got to do it. Does that make sense? But that's the most you could do because you don't know G. Any other questions on IVT? Yeah?
Can we do 19?
Sure. Where is it? There's a 19?
Yeah, there's not really.
Oh, there's more? Man, I'm a slave driver. Okay, cool. Right on. This is a great problem. This is a very common AP multiple choice question, which I don't have, but I think on tonight's homework there's an actual AP multiple choice question like this, so this is good practice. Because I am getting a little picky with you, you'll have to show a little more work than you might have to do on a multiple choice, just kind of find the answer thing. So this is the work I would expect to show. Remember the definition of continuity. Is this the right problem? Did we use we did IVT after continuity? Oh, okay. So actually this week I wanted continuity first, which you've already turned in, then IVT, then the derivatives. Okay, sorry. So the definition of continuity, remember, it's that the limit as x approaches a number exists, which implies that the one-sided limits are equal. The point exists, and that those have to be the same. What the function approaches and what the function is have to meet. Their whole scope. Okay? So that's what we're going to look through, and that's what I'm going to follow. You can't follow the definition of continuity to show the work properly if you don't have this in your brain. This is your starting point. You've got to follow the steps. So in order to show part 1 is happening, with a piecewise, I need to show the one-sided limits. If I approach 1 from below, then I am going to be using the k minus e to the x function. As x goes to 1, what does k minus e to the x go to? K stays k, e stays e, x goes to 1. So the left side limit is going to approach whatever k is minus e. The right side limit is using the other branch, which is 3x plus 2. It's pretty common in piecewise that you don't just call it f, you stay at f, you then go to, hey, this is the branch I'm using. And at 1, this would approach 5. Do you agree? This would approach 3, but then approach 2. Right? All right. Now, if the limit exists, then these two have to be equal. So if I want to make this continuous, I need to set k minus e equal to 5. No. Okay, the limit is k minus e. At 1, it's k minus e to the 1. So no x. And if I see this, that's a big no. You do not understand what's going on. Okay? You want them to meet not at some x, at x equal 1. 1 is in. Okay? So k minus e to the first equals 5. Therefore, k equals 5 plus e. Now the rest of this you could go through, but I really used the definition to get myself started. F at c exists. Do you agree that f at 1 exists? Because it's defined, and the limit has been satisfied because you'll see that 3x plus 2 is 5, and that equals the limit, which is 5. All right? Let's actually go here. This was the left-hand limit. Before I knew k, I said the left-hand limit was k minus e, yeah? Now I just said that k is 5 plus e. If that goes in, then 5 plus e minus e is 5, and therefore the limits will agree. Do you see? Okay. Other questions on this? Actually, I won't take any more questions. Sorry, I'm done. Moving on. How about, what's this? Are you kidding me? Man, this is a lot. How about the set 19? Let's get that turned in. How did set 19 go? I have some problems up here, but I'll take anything that you have questions on. Do you have any questions on set 19?
Are those the ones you're going to do?
Only if you need them. Did I post this?
No.
Oh, well, then that's it. I did not post. Oh, so that'll help, the key will help with the book problems, but these are replacement problems. So you need the answers to these, is that correct? Darn it, I thought I posted this, I'm sorry. Why did I do the key if I was just not going to post it? That's crazy, I don't even practice. All right, here we go. Let's see. Did you get for this bad boy? Unrationalized, I got 6 over 5 root 13 minus 2 root 21 over 5 root 13. How about you? Yeah, that's what I got. Or no, where the heck is that coming from? Which one? Are you good? No, okay. I didn't, okay. So, first of all, can you get started? Tell me what's the sign identity for sine of a plus b. Sine a cosine b plus sine b cosine a. Okay. Now, they are asking me for sine of a plus b, so I need to find each of these 4 components. Sine of a, what is it? 2/5, they give it to you. Cosine of b, what is it? Yeah, so that's where we start having problems. Okay, so let's draw pictures. If I draw angle A, it's in first quadrant. What does sine of A equal 2/5 tell me? Sine is a ratio of SOHCAHTOA, opposite to hypotenuse, yes? So opposite to hypotenuse, yeah? 2 to 5. Sorry, my picture's all funky. Now, to do the cosine is adjacent to hypotenuse. I need the adjacent set. What's the adjacent set? Root 21, okay. So what's the cosine of, this actually is terribly worthless because I'm drawing angle A. This is A. Does that help me find cosine B? Not so much, but I'll need this later, so hang on with that. Okay. B, I could draw by drawing this. What's tangent the ratio of? Okay, so opposite is 2, adjacent is 3. You might be saying, wait a second, isn't that negative? How can this be? Well, yeah, they actually are negative, but because I'm getting negative 2 over negative 3, it's coming out to be positive 2/3. You follow? So what's the hypotenuse? Root of 13. The hypotenuse is always positive because it's the sum of 2 positive squares. All right. So root 13, checkity check. Now I'm ready for cosine B. What's cosine B? Here's B. Yeah. Adjacent over hypotenuse, negative root 3 over square root of 13. That's where this came from. Okay? Sine B. What's sine B? Negative 2 over root 13. What's cosine A? Root 21 over 5. This is not a big Saxony kind of problem, but it's super common in most trig folks at other schools. So,
It's a negative
Negative
6.
6.
yeah. Oh, yeah, good call. Boo me, yeah, negative 6. All right, we're good? Okay. I'll get you started, but I wanted you to understand the point, basically. The point is, and this is a calc prep kind of question. When you solve a system, what are you finding? Intersection points. You're finding intersection points. When you solve a system of equations, you're solving for intersection points. Therefore, when you graph this, like that, or something like that, then you should be giving x's and y's. I had two. Well, I didn't do this. Okay, intersection points. Did you get 2 intersection points or 3? I can't remember. 3? Oh, cool. Okay, intersection points. Now, once you find those intersection points, this is also a calculator skill you must have, being able to find intersection points. Once you have those intersection points and you record them, part A is good and part B is easy. Now, this is part of the question is, do you understand the difference between these two? You can see that it's similar in that I'm asking, like this, when you're finding intersection points, you want to know when they're the same. This kind of what this is going on here, you want to know when they're equal. The difference is the answers. What kind of answer will you give to B? Just x. You're giving the x that solves the equation, all right? When I solve this equation in pre-algebra, your answer looks like this. X equals blah, right? It's not, you're not going to give me, hey, it's x. You're not going to give me, oh, x is -2, and when x is -2, y is -5. This is a stupid answer. That's not, you solve the question. You say, what's the x that makes it true? Same goes here. You're giving me the x that makes it true, so you're only going to be giving me the x's of the intersection points, the places where they come out the same. You understand? Yes? No? Yes, you do. Okay, 21. Let's see how we did. This is IVT, yes? F is continuous. Don't be a wise guy and say, well, that's capital F, so it's different. You know what I mean, all right? Stupid autocorrect. So let's move along. What do you start with? Although it said you have to say it too to show that you know it's a condition for the IVT. F is continuous. If you wanted to say given off to the side, that's true, but you don't need to. Now what do we do? IVT work. This is on a test next week. F at 0. Find the endpoints. F at 0 is -8. F at 5 is 3. Determine if what they ask about is between. F equals 2 is between F at 0, or between -8 and 3, yeah? In other words, as F goes continuously from -8 to 3, it must pass through 2. I think you'll agree. And so we can conclude by IVT, there is a C in, where is C? You might as well just use just look back at the question. There must be a C where C is between 0 and 5, such that F at that point has to equal 2. There's got to be some point in between where y is 2. Check. Okay. What did you get for, or let's see how we're doing here. What's the point here? Oh, yeah, good point. Okay, this is a good one. Humding. Yay. Very common calc starting error. What'd you get for an answer? Did you say -4? You lose. Boo. Okay. What is the answer, people?
6.
-6, because a limit is what the function approaches. And if you're approaching one, you're not at one. And if you're not at one, you're not equal to one. And if you're not equal to one, then you are here. Okay? And so that's -6. What's going on graphically here? It's a graph that looks like this, like a parabola. The only problem is at 1, there is a hole. All right? That's a great gotcha problem in AP Calculus, or in all calculus. All right. If you talk this guy and show it is or isn't continuous at x equal 1. First thing is, does the limit exist? In this case, it would mean do the pieces meet, the branches meet. The left, x approaches 1 from the left of f is going to be the x squared minus 7 branch, and that limit is -6. As x approaches 1 from the right is the x minus 5 branch, that is -4. Right away, I can see the answer is a big old no. You don't have to go to condition 2 and 3. You can just say f is not continuous because you could say the one-sided limits are not equal. You could say the limit doesn't exist. Or you could even say because -6 is not equal to -4. I think. All right. Do you have other questions on 19? I understand that you guys are free for 7th hour, but I have 7th grade pod meeting, so I cannot help you. I will be here after school, but do we achieve our goal? Can we get these 2 homeworks by the end of the day? Yes.
Number 7, you talked about how this has
The domain of, which one? The domain of fog?
Yeah.
Yes, I will be happy to. First of all, let me catch up to you. Fog would be g into f, that's log of 1 over x. The domain. Now, we actually have 2 issues. There are 3 restrictions on domain. You can't have the log of 0 or negative. You can't have a 0 in the denominator, and you can't have a negative in an even root. So we have 2 operative problems here. In terms of what's going on here, we cannot have a 0 because of the denominator element, and we cannot have anything that ends as 0 or negative. So that implies that x cannot be negative either. So x then must be strictly positive. Does that make sense?
Yes. It's the same thing.
1 over x, range is actually harder for that. 1 over x for only positives, what's going to come out of this is only positives. Actually, no, that's fine. Never mind. Yeah, the range is then, if only positives go into natural log, then that's fine. As far as what comes out, log can be anything, all y's. So it's all reals. Make sure I get those 2 homeworks by the end of the day. Have a great weekend.
Thank you.
Thank you. Have a good weekend. Make sure you run that dash tomorrow.